Welcome to the Discover Engineering and Turn Your Ideas into Reality video and webinar series, sponsored by Siemens. Today, Tess Strauch will be presenting on exploring engineering through project and problem-based learning.
Thank you, Strauch. Welcome to Exploring Engineering Through Problem-Based Learning. My name is Tess Strauch, and I work at BethPage High School. So a little bit about me. I am in my 8th year of teaching, and this is my 2nd year here at BethPage High School, which is located on Long Island, New York. I currently teach AP Physics 2, Regents Physics, Marine Biology, and Principles of Engineering. I've previously taught chemistry, biology, and physical science in South Carolina and in Brooklyn. This past year, I started learning engineering for the very first time. And so I learned the basics of engineering, CAD, and 3D printing through the Siemens Engineering Design curriculum, which really uses problem and project-based learning as the base of the curriculum. I also incorporate project and problem-based learning in most of my classes that I teach, mostly because I, as a student, when I was in big lecture courses, I did not succeed. I really thrived in the small upper level research-based courses where I was able to get hands-on and learn the material by doing. So I've implemented hands-on learning from the beginning of my teaching career because that, I believe, is truly how students learn. So what is project or problem-based learning? Problem-based learning, or PBL, is a teaching method in which students learn by actively engaging in real-world and personally meaningful problems. And that's a quote from PBL Works, which is a resource that I really love to use. It's a problem and project-based learning are similar techniques. Problem-based learning is where you are presenting a problem to students that they solve, and project-based learning is where they have a project to present at the end. I will use both terms synonymously for this presentation, and I will refer to them both as PBL. So the standard way of teaching and learning, sort of the old school way, is standards-based learning. And this is simply because most courses are designed after standards. Most states have standards that they require courses to be taught to. A lot of other courses or programs write standards, so teachers have a guide to creating their curriculums. A lot of teachers approach standards-based learning through notes, worksheets, typical labs, videos, but project-based learning and problem-based learning, PBL, really approaches the same standards to still test what students know, but through solving problems and creating projects. So typically, PBL courses are taught by presenting a real-world scenario paired with a few notes and background information. And then students have to solve this problem based on research and doing and hands-on activities. An example of problem-based learning that I have used in my classroom to start my marine biology course the past 2 years is from here locally on Long Island. On Long Island, we've had one of the most intense brown tides in the past few years. Brown tides are caused from nitrogen fertilizers leaking into groundwater, in addition to septic systems leaking into our aquifers and our groundwater. Unfortunately, that's the same groundwater that we have to drink. And so I present this with students, to students, as a problem. We have to drink this dirty water. But as individuals that live on Long Island, we don't actually drink dirty water, we drink clean water. So how do we get from this issue of the brown tide to having clean and drinkable water? So my students are challenged with the problem of taking dirty water and cleaning it using water filtration systems. So here on the right is an example of my students taking dirty water and filtering it out, not completely clean, not drinkable, but using the resources that they have to solve a problem. We then transition this project into how the brown tide may be impacting other organisms of the bay, et cetera, into our curriculum. This could have been approached through standards-based learning of having students learn the water filtration systems and the step-by-step techniques, but my students learn by doing the actual project. These problem-based learning activities come from a whole range of different sources. The Siemens Engineering Design curriculum is what I use in my engineering course. I've also in the past used Edutopia, PBL Works, and the project approach to gather ideas for my different PBLs in my physics classes, my marine bio classes, and my chemistry classes. All of these resources are available online through Googling, through a lot of research. And the best part about problem-based learning is once you have the system and the structure of the problem-based learning, as long as you have a new problem to solve, you can use that same structure for most projects. So how do we do a PBL? What are the steps for implementing this? So the steps for implementing a project-based learning start with the essential question, problem, or project. Then design a plan for the project, create a schedule. As the teacher, you don't do much of the work, but your work is to monitor the students and the progress of the project throughout the entire process. Assess the outcome. What are they going to present? How ready are they for those presentations? And then evaluate the experience. Give them feedback so the next project can be a step better and more complex than the last one. These steps are worded from the teacher's perspective, but I like to throw these steps back to the students. I give the students an essential question and I have them design a plan for their project and create their own schedule once I give them a deadline. I personally keep monitoring each other, but they're also working in groups so they can monitor their own progress and keep each other in check. I also like to give students the chance to evaluate their own experience and give me feedback for the next time I try the same project or future projects and how we can improve. I am going to focus the next few slides on specifically my engineering course. And this is a survey that I gave my students at the end of the year last year, which again was my first year using the Siemens engineering curriculum and teaching engineering in general. On the right-hand side, you'll see all of their responses for a very general question. I said, what class activities and assignments do you feel were the most beneficial to your learning? And this was of the whole year. And most of their responses mentioned the CAD software. What was interesting is if you look on the left-hand side with all of the projects I included, only 4 of those were hands-on activities and the rest used a CAD engineering software called Solid Edge. I expected more students to say those hands-on experiences were their favorites and the most beneficial, but their hands-on experience using CAD software for these future engineers were the most beneficial to their learning. I'm now going to share an example of a project that I do with my engineering students to show how I blend PBL with the engineering design process. So to start any PBL, I always start with an essential question or problem. So the question for this project was, how can we create a challenging 3D puzzle for a particular age group and appropriate difficulty level? You see here an example of a 3D puzzle that has been 3D printed. So once students are given the essential question, then I present them a scenario and ways to problem solve through this scenario and ways to actually accomplish the project. So the scenario is a large office supply company wants you to design this project, this puzzle, and they will be displayed in the future. So this is a really small motivation that gets students thinking big about where their project is going. It's not just because Ms. Strauch wants them to create a puzzle. It's because, oh, they have to sell their puzzle to a large supply company. So it's a mini motivation that'll get students interested. So to get through this entire process, I always make students brainstorm and sketch their ideas. Here's an example of some student engineering notebooks where they are throwing a bunch of ideas down on paper and showing their peers what they're imagining. They also, I encourage them all to do research and to sort of tell me what the inspiration behind your design was. What research really led you to your ideas? Once they've brainstormed, they've sketched, they've discussed with their partners, then we go to the Solid Edge program, which is a CAD program free for high school students, which is amazing. So here we have 3 different steps in the process of the Solid Edge program where my students sketched their individual pieces, they assembled them together, and then they show the exploded views so we can see how those pieces fit together. Once my students have 3D models, I then ask them to make a prototype on the computer through the CAD program called Keyshot Rendering. And this shows how you actually solve the puzzle and the expected colors that they would want to present this puzzle to the supply company. So this design was sort of a Rubik's Cube puzzle where each of the pieces fit together, had their own unique colors, and they were able to tell you the step-by-step solution. At the end, there's always some sort of presentation or report that I ask my students to do to show their understanding. I still want to make sure that my students are learning the process and learning the vocabulary and learning throughout this process. So here's an example of an engineering report that some of my students did that has all of the nomenclature, all of their steps to solution, and the summary of the project. And then at the end, my favorite part about PBLs is that all of the different students come up with a vast range of ideas. While a lot of these look similar, they all had their own thought behind them. The Rubik's Cube on the top left with the red, green, and blue, they were able to put those pieces together in 8 different ways successfully. One group thought of a ship. That ship actually comes together in different pieces. And then in the top right corner, you see a number block that you have to move those individual pieces around to get the count from number 1 through 15. So all of these students were presented the same essential question, the same scenario, but they were able to create their own designs. And so their own personalities and creativity were able to shine through. So overall, PBLs are fantastic, but what is my suggestion of a key to success for PBLs? And that would be outside collaboration. In order to make sure that your PBL really hits home with students and that they remember it, having someone else besides just you tell them what to do is really huge. So here are a few examples of how I've incorporated outside collaboration. On Long Island, we had our first 3D printed home out east from where we have our school. And so I showed them a clip of, look, this is 3D printing is being used outside of the school, outside in the real world. Let's design our own houses that maybe we could send them our blueprints and maybe they would want to 3D print our house. I also, my students were known for their 3D printing, and they were recruited by our science department to create trophies for the Marshmallow Madness challenge that we participated in this past March. So my students created animals for the top 4 final 4 choices, and then my students voted on the best ones. Here's the kangaroo, which was the runner-up, and the kangaroo won, and the harpy eagle was the runner-up. So you see those 3D printed and spray painted trophies that real students were able to take home. Another suggestion is to, again, incorporate outside people. I like to incorporate other teachers in my building. So for one of our projects, our chess sets and our kitchen tools, I asked students to go interview another teacher and ask what they want. If they were to take home a chess set tomorrow, what would their design of the different pieces be? And then my students were able to create their designs based on those constraints. And then the hands down favorite project that my students did, again, was with another collaboration of our librarian, who is a chocolate maker. So my students designed chocolate molds. We learned the steps of creating a silicone mold, and then we learned how to actually make chocolate through those molds with the help of our librarian. So again, getting that outside collaboration really takes students to see what their work is and see how it's actually being meaningful. So overall, I've had a great success with PBL, and this quote really stands out to why PBL is so successful in my classroom and in classrooms everywhere. Research shows that by organizing learning around meaningful goals, PBL can be an effective way to cultivate a need-to-know attitude in students. Students are motivated to deepen their understanding in order to solve a problem that is meaningful to them. Concepts are better understood when students see a need for their use, because that need encourages them to apply what they're learning to relevant situations, leading to a better sense of understanding. So in general, my students started not knowing how to do anything in engineering, essentially, with any of their sketching, with their designing, with the engineering design process. And then by the end, through this PBL approach, they really enjoyed the class. And here are some survey results that prove that to be true. And not only did they really enjoy it, but by looking at these images, you can see the vast change from the beginning project to the end project of the detail and of the success that they had. And I've seen this in every course that I've taught in physics and marine biology, that when we do PBLs, they really do set students apart from what they need to know and what they want to know and how they learn. So with that, everything that I discussed is cited here, and thank you very much.